Hello guys and welcome to another Leetcode question. Today we'll be solving find median from a data tree. So basically what we have to do is find the median of an array. Median of an array is the middle value. If there are two middle values, it is the average of those two values. But in this case, what is special is the array is not static, it is changing. Continuously values are getting added to it. So let's say we have any algorithm to find the median. Would be like array of uh, so this array it also won't. There is the middle value is the same as main value. Yeah. So the input that is coming, it might not be sorted, right? In this case, we see that 2 and 3 and 4 they're coming in the sorted order, but what if after 4 we get one, right? One will go to the start of the array, so the whole array would need reshuffling, and then we'll have to find the median. So as you can see that the normal method of iterating, like having an array, just taking the middle value won't work. As for every new value, we'll have to sort the array. Sorting an array was n log n, and that will be done n times. So yeah, that is why that approach won't work. However, there is another approach of doing this, that is by using heap. So the plan is that we'll have two heaps. Imagine heap 1 and this is heap 2. This one will be min and this one will be max. So this will be max. So imagine you have an array like this, and there's a middle portion. So all the smaller elements would be here, and all the bigger elements would be here. So whenever you get a new, let's say you get I, correct? You get I. So we'll either put it in this array or this array, correct? So since this is a max heap, you know the largest element here. We can compare I with the largest element. If I is less than this, we can put it in this. If I is greater than this, then we can put it in this heap. Now these heaps, they will have to follow a property that the number of elements, the difference of number of elements should be 1 at max. It cannot be more than 1. So if the difference of number of elements is greater than 1, like let's say there are 2 elements extra in this one, that probably means that we can do some reshuffling. Our goal is to the number of elements, they should be as equal as possible, equal, but there can be a difference of 1, as we know that if this number of elements in this array is odd, one will have more elements, but only one extra element, and that extra element itself would be our answer. Got it? So let's get back to the question. So firstly, we'll need two heaps. Let me declare the heaps here, and then we can initialize them. So they will be integer only. So this is min. Okay, let me call this first, and the other one as second. The first one is a max heap, and second one is a min heap. First, and so I'll make this as private. Come on. Okay, so we have two arrays. So whenever the class gets initialized, first equals to new. So this is actually a max heap. So for a comma b, this is again a custom comparator. We'll return b minus a, and copy and paste. This is second. So this is a min heap. So for a comma b, we can return a minus b. So this is a min. One second. So this first one is a max heap. For max heap, we can do b minus a. Second one is a min heap. We can do this. We can skip doing this as well, because by default it is a min heap only. Correct. Now we have first and second. So whenever we have a number that we want to add, so if first uh, first first is not empty, and first dot peak would be the topmost element, which is the largest element. If that is um, greater than, okay, let's call it the greater than the number that I want to add. So in this case, what we'll do is second dot add peak pool. Yeah, second dot add num. So we'll add it in second. Else we'll add it in first. Now what we'll need to do is rebalance. We can either so elements are only getting added, they're not getting removed. So we can probably do the rebalance here only. So if Mhm. First dot size. Okay, let's have the rebalance methods inside this only, so that the logic is separated well enough. So second dot add. So we have it in second. Now if second dot size minus first dot size dash is greater than 1, this is a problem. So what we'll do is, okay, CCON. So there's an element extra in second. So first dot add and second dot pull. Correct. And the same thing probably here. If so, it got added in first. So if first dot size minus second dot size is greater than 1, then we'll do second dot add and we'll add first dot pull. Correct. So we have this, and we don't need this. So we have added successfully. Now we have to find the median, and median can be double as well. So if first dot size, so median can be in any of the heaps, because we're always rebalancing it, and we have kept the insertion open. It can be in this first array or the second array. So if first dot size equal second dot size, so we'll do something else. If first dot size is greater than second dot size, so we know that first has the element, so basically return first dot not pool, we have to peak, otherwise we'll return second dot peak. Now in this case, double answer equals to, so these will be coming out as integers, and we have to get their average. First dot peak plus second dot peak. Now since these are integers, um, okay, I'm assigning them to double. That is fine, and we can return answer by 2. So if I do this plus this by 2 here, there is a chance that they'll be assigned to an integer that would um, take the floor of the value. Otherwise I'll have to explicitly say double here, which I find unnecessary. We can just do this. If they're assigned to a double, answer by 2 should give you the final answer. All right, I think we can test this. Okay. Okay, so we have this. If new number, if the size first dot peak and then first dot peak is greater than this. Okay, this is a problem. If first is not empty and the highest of first is less than num, then I'll add the number in the second one. Now since it is added in the second one, it's if its size minus the size, it's exceeding 1, I'll pop it from there and put it in first. Otherwise it goes in first. Same thing followed here. All right, perfect. So this is working. Let's try submitting this. Wonderful. The complexity is still quite high. I'll check the solution. 59 milliseconds. Okay, I'm just thinking if any optimization is possible here, even of the smallest. No, no, answer by 2. Can't do anything here. With polling, adding. Can avoid one operation here. I'm adding and then removing it. So since it has to go to second, but if second dot size minus first dot size, mm, if it's already 1, then let's put it in first only. So if its size was 1, that's how it became size 2. So if it is already 1, equal, if this is already 1, I, okay, I won't do this. If second minus size, if this is already 1, then let's add it in first. Okay. Otherwise, we'll add it in second. The same thing here. Add it in first. Second dot add nums. Let's run this. Oh, this has to be equals to 1. First dot add nums. What is the issue? Num. Perfect. That should help a little. Mm, what happened is we have add number here, adding number. One simple thing is always add in second and then you can rebalance since it was last time rebalanced. Yeah, we don't need these many checks. Directly add it in second. Anyways, we don't. Yeah, this is quite complicated. Just like simply add it in second always. Let's do this. Yeah, you directly add it in second. Now, what is possible is this. So this is the logic simplified. You have a new number. You add it in second. Second would definitely be overflowed now. Now, if second dot size minus first dot size is greater than 1, it has exceeded 1. The first dot add num. First dot add second dot poll. You remove it from second and you add it in first. So this would maintain your size difference as maximum as 1. And now here in this case, if the sizes are equal, then you do this. Uh, uh, else you could just like do second dot peak because second would always have the one extra element. And this is the logic simplified. So you don't have those many. Okay, same issue. Yeah, I wonder why. Oh, okay. I got it. Yeah, we can't do this. We have to be sure where we're adding the element. That is crucial. That element is lesser than if num is greater than the peak, then only it should go to the. Otherwise, some other element is going there. This one won't go. When you add it in first and then you remove it from there. Okay, so what I missed is I wanted to simplify this, so I said if whatever I get, I'll just put it in this and then I remove it. That is wrong. And then before this, I said, oh, I do this, so I put it in the second one and then take it out directly. I can do this, right? But the issue is when you put an num into first, it goes into a max heap. So something else can come out when you're doing poll, and when you put something into second, it is going into a min heap. So something else can come out when you do poll. So when you do poll on second, the minimum element comes out. When you do poll on first, the maximum element comes out. It it won't necessarily be the new element that you just inserted. So that is important because we're somewhere trying to have a sorted array. The middle part of the array sorted. Imagine it like that. The left part is in a heap, right part is also in a heap. The middle part is always sorted. So that's why you need to make sure that the insertion is in the correct array. All right, let's see. Yeah, this was submitted anyways. Um, all right, yeah, it's still 94 milliseconds. Uh, so frequency you have jump, you have lower, higher. Yeah, the solution is not intuitive at all. Oh my god. It's just when you look at this solution and you look at this solution, the answer has to be the code has to be readable. This is nice. It's the same thing. That's good. All right, cool. Thanks for joining in. I'll see you in the next one. Bye bye.